So hello students, in this video we will be discussing about energy of the revolving electron, and in the previous video we have discussed about Bohr's atomic model in which we have derived the formula of velocity of the electron revolving around the nucleus in any orbit, and we have also derived the the value of r, that is the radius of the orbit in which the electron will be revolving. Here we will be discussing about the energy of the revolving electron. So we know that total energy is always equal to the kinetic energy as well as the potential energy, that is the sum of the kinetic and the potential energy. We know the formula of kinetic energy, that is 1 by 2 mv square, and in case of electrostatics the potential energy is equals to 1 by 4 pi epsilon naught multiplied by the product of charges divided by r, the distance between the charges. Let us consider the distance of the charges, that is, this is the nucleus, this is the electron, this is the electron, this is the nucleus, and the distance, let us consider this distance is r, and the charge on electron is a negative, and the charge on proton, or the total charge on the nucleus is positive, that is plus of E. So that is 1 by 2 mv square, this minus and plus becomes minus 1 by 4 pi epsilon naught E multiplied by E is E square divided by R. Let us consider this is equation 1, and we also know that from the Bohr's first postulate that centripetal force is always equal to electrostatic force of attraction, that is mv square upon r is equals to 1 by 4 pi epsilon naught E square upon R square. So from here we can conclude that this r and 1r gets cancelled. So we are left with mv square is equals to 1 by 4 pi epsilon naught E square upon r. So putting this value of mv square in equation 1 here in place of kinetic energy mv square, we get that E is equals to 1 by 2 mv square is equals to 1 by 4 pi epsilon naught E square upon r minus of this whole part, that is my 1 by 4 pi epsilon naught E square upon r. Here after calculating it, this is 1, this whole part is common, 1 by 4 pi epsilon naught E square upon r, 1 by 4 pi epsilon naught E square upon r, this whole part is common. This is, if it is nothing here, it is 1 multiplied by 1 subtracted by 1 by 2 is becomes minus 1 by 2. Therefore we get to the conclusion so far here that E is equals to minus of 1 by 2 multiplied by 1 by 4 pi epsilon naught E square upon r. So we have been knowing that the value of 1 by 4 pi epsilon naught, we have considered it as a constant k, that is k multiplied by E square divided by 2 multiplied by r. And we know the value of r. In the previous video we have studied that it is n square h square divided by 4 pi square, we have to put square over here, this is 4 pi square k me square. So here after simplifying it, 2 and 2 gets cancelled, 2 left over here, this becomes 2 pi square k square, this is k square as well, k square m e square, this is not k square, I mistakenly wrote it here, this is k multiplied by k is k square m e square, and square becomes e to the power 4 divided by n square into h square. So here this 2 is constant, pi is constant, k is constant, m is constant, e is constant as well, and h, that is Planck's constant. So only thing we are left with, if we remove all the constant, we consider that we get that E is directly proportional to minus 1 upon n square. So this value, the constant, all the constant that we have considered, the value of that constant is 13.6, and the whole E becomes minus 13.6 divided by n square, and the unit is electron volt. This is considered as electron volt. So this is the energy of the revolving electron. Thank you very much for watching the video.